Hi, this is Mrs. Cotter. We're going to go over week 9, day 2. Alright, so it says the daily warm up. It says color tetraminos on the grid below to A, create a square with an area of 16 units. So here are the tetraminos before. We have 5 tetraminos. We're going to focus on A first. It says create a square with an area of 16 square units. So the tetraminos that I might use are going to be these ones because these are a rectangle and a square, and these are a little bit easier to work with than these. Now you can try making a rectangle or a square with these ones, but it's going to be a little bit tricky. So if you want to challenge yourself, you could use these. But I'm going to show you using these ones. So if I need to make an area of 16 squares, I have to think, okay, well, how many squares are in this tetramino? Well, there's 4. So 4 times what is going to equal 16? Well, I know that 4 times 4 is going to equal 16. So I'm going to go 1, 2, 3, 4. So I made this first tetramino right here. And I'm going to go 4 across. 1, 2, 3, 4. Now, if you remember, when we learned the area, 4 times 4, the length times the width, is going to equal your area. So 4 times 4 equals 16. Now, I could count each square if I wanted to, but that's going to be a lot. But if you know that length times width equals the area, then you will know that 4 times 4 also will equal 16. All right, and that's a little bit of an easier way to do it. Now, B says, create at least 2 different rectangles, each with an area of 24 square units. So I'm going to again use this one. So I know that, so I need to think of 4 times what is going to equal 24. So here I have my length of 4. What is going to be my width? 4 times what equals 24? 4 times 6 equals 24. So I'm going to make my width 6. 1, 2, 3, 4, 5, 6. And I'm going to go down. 4 times 6 equals 24. So that's one of my rectangles. Now another way that I could do this is I could just switch my length and my width around. So instead of having my length 4 and my width 6, now this time I could make my length 6 and my width 4. Now I still have this tetramino I'm using it. I just flipped it around right over here. And now I just use the commutative property of switching my length and my width because 6 times 4 also still equals 24. And I clearly made 2 different rectangles and I just switched the tetramino around. And again, you can use these and make different squares. It doesn't have to be exactly like mine. Alright, let's move on. It says new learning example number 1. It says label the following models as fractions inside the boxes. So I have a hexagon right here. Now this whole entire hexagon equals 1 whole. Now I took this hexagon over here and I split it into 2 pieces. So I have 2 pieces shaded and I have 2 equal pieces. So this fraction for this hexagon is now going to be 2 over 2. Now I took the hexagon and I split it into 6 pieces. So I have 6 pieces shaded and I have 6 over 6. So this fraction is going to equal 6 over 6. Now over here, I just took my whole hexagon and I copied it 4 times. Now I didn't break this hexagon apart. So it's still going to equal 1 whole. But what I did is I took 4 of these hexagons and I pasted them. And each of these hexagons equals 1 whole. So it's going to be 4 over 1. And you can see that 4 copies are shaded. Right now we're going to try this. So now we have a triangle. It's going to equal 1 whole. Well, how many pieces are shaded? We have 4 pieces shaded. And how many altogether are there? How many little triangles are inside of here? 4. So it's going to equal 4 over 4. Now this one is a little bit different. I have 2 of these rectangles. So how many pieces are shaded? 1, 2, 3, 4. 4 pieces are shaded. Now let's look at this rectangle. let's just look at the first rectangle. How many pieces is this rectangle split into? It's split into 2 pieces. This rectangle is also split into 2 pieces. So we just need to consider one rectangle equals 4 halves. So let's look at it this way. If I have this rectangle, I know that this piece is going to be 1/2. This piece is going to equal 1/2. This piece equals 1/2. And this piece equals 1/2. If I was to add 1/2 plus 1/2 plus 1/2 plus 1/2 4 times, I know that I would first do 1 plus 1 plus 1 plus 1, which equals 4. And remember, the bottom number doesn't change. The bottom number of each of these fractions is 2. So it would be 4 halves. So when we're trying to figure out the bottom number, you want to just look at one of the pieces and see how many times it's split into. In this case, this triangle is split into 2 pieces, so it would be 4 halves. Alright, let's look at this one. It says fill in the missing whole number in the boxes below the number line. Use a pattern to rename the whole numbers as fractions in the boxes above the number line. So if we look at our number line, at the bottom we have whole numbers. It's counting up by 1. 8, 9, 10, 11, 12, 13, 14. On the top of our number line, we have fractions. So 8 is going to equal 8 over 1. Remember, if it's at the same tally mark, it's going to equal the same. So 8 over 1 equals the same exact thing as 8. The same thing goes for 9. 9 over 1 equals 9. 10, the same thing for 10. 10 over 1 equals 10. So 10 over 1 is going to equal 10 because anything with a 1 at the bottom is going to equal a whole number. Alright, if there's a 1 at the bottom, you know that we're going to have a whole number. Alright, so now it's our turn. So on our number line, we can see at the bottom that they're skip counting by 2. 0, 2, 4, 6, 8, and so on. So 0, the fraction for that is 0 over 1 is going to equal 0. Remember, anything over 1 is going to be a whole number. So they did 2 for us. 2 over 1 equals 2. What about 4? So 4 over 1 is going to equal 4. Remember, 4 over 1 equals the same thing as 4. They're at the same tally mark. What about 6? 6 over 1 is going to equal 6. What about 8? 8 over 1, they did that for us. 10 over 1 equals 10. Also did that. What about 12? 12 over 1 equals 12. Alright, good job. Alright, now it says new learning, example number 3. It says explain the difference between these fractions with words and pictures. So they want to know the difference between what 3 over 1 is and 3 over 3. So in this picture, they show that a rectangle equals 1 whole, this whole entire rectangle. In this one, this is 3/3. Well, I know that this is 3/3 because, well, I know that's split up into 3 pieces, and they're shaded, and I have 3 pieces. But when I look at 3/3, another way that I can figure out that it's 3/3 is that what's a unit fraction of each of these pieces? Well, it's 1/3. Each of these pieces equals 1/3. That's a unit fraction. Now that's different for these. These ones are showing the whole entire piece, and they just copied it 3 times, and it's shaded. So if I have 1 whole, 1 whole, and 1 whole, I have 3 holes, and it's over 1. So this is 3 over 1. This picture is very different than this one right over here. They're different fractions. At the bottom it says the fractions 3 over 1 and 3 over 3 are different because they both represent 3 copies, but the units that are copied are different. The fraction 3 over 1 shows 3 copies of 1 whole, and the fraction 3 over 3 is 3 copies of 1/3. Just like we said, this shows 3 copies of 1 whole, this shows 3 pieces of 1/3. Alright, so this is now our chance to figure it out. So let's explain the difference between these fractions with words and pictures. So I first drew 5 over 1. I made 5 copies of a rectangle, and it equals 1 whole. So you can see that it's not split up. So I made 5 copies of 1 whole, so that equals 5 over 1. Now this one is 5/5 because I took one of these, my rectangles, which is one whole, and I split it up into 5 pieces. So each of these is a piece of 1/5. We have 5 copies of 1/5. So that equals 5/5. Now you can see that these pictures are very different. This is 5 copies of one whole, and this is 5 pieces of 1/5. So you can see it's 5/5. Alright, now it's our turn. Let's split this up. Alright, let's look at this piece first. It says label the following models as a fraction inside the dotted box. The first one has been done for you. So we have a rectangle. It equals one whole. Now we can see that this is 3/3 because there's 3 pieces shaded and there's 3 pieces. Remember, we've talked about this before. Each of these pieces is going to equal 1/3. That's another way that it shows me that this equals 3/3. Now let's look at this one. How many pieces are shaded? 3 pieces are shaded. Now this is where it gets tricky. We want to look at the first rectangle. How many pieces is it split into? It's split into half. The same thing, this one is also split into half. So that is going to be my bottom number. This is going to equal 3/2. 3 pieces shaded, and I know that these rectangles are split into half. So that's going to be my bottom number. Now let's look at this. We have 3 copies of one whole. So I know that 3 copies, and each of these equals one whole. So it's going to be 3/1. All right, let's look at our second one. How many pieces are shaded? 4. And we have how many pieces all together? 4. So this equals 4/4. Now this one's going to be very similar to the one above. How many pieces are shaded? 4. And what are these rectangles split into? Let's look at just the first one. Split into 2 pieces. Both of these are split into half, so that is going to be my bottom number, 4/2. Now, how many copies of the rectangle do we have now? Well, we have 4 copies of, remember, one of this whole entire thing shaded is one whole. So we have 4 copies of one whole, so 4/1. Now we need to fill in the chart. So 10/1, remember anything over 1 is going to be a whole number. So 10/1 is going to equal 10. 11/1 is going to equal 11. What about the fraction for 12? What's it going to be? 12/1. What about the fraction for 13? It's going to be 13/1. What about 14/1? It's going to be what? It's going to equal 14. Remember, anything over 1 is going to be a whole number. 15, the fraction for that is going to be 15/1. And remember that these equal the same thing. 15/1 and 15 equals the same. And 16/1 is going to be the same as 16. Remember, these all equal the same because it's at the same time mark. 10/1 equals 10. 11/1 also equals 11. Same thing. Alright? Now it says explain the difference between these two fractions with words and pictures. 2/1 and 2/2. Well, I'm going to draw 2/1. I know that 2/1 is going to be 2 copies of one whole. So I'm going to make a rectangle. So I'm going to make 2 copies of one whole. And I chose a rectangle. And you can use any shape. You can use a triangle or a square. I'm going to use a rectangle because it's easier for me to draw. So I have 2 copies of one whole. 2 rectangles, and they're not split. They're one whole. So this is going to equal 2/1. Now I'm going to draw 2/2. Well, remember my rectangle equals one whole, and I'm going to split it in half. Now I know that this is 2/2 because this piece is 1/2, and this piece is 1/2. If I was to add 1/2 plus 1/2, that would give me 2/2. 1 plus 1 equals 2. The number on the bottom stays the same. 2/2. So these are different because this is 2 copies of one whole, And this is one whole split into 2 pieces. Alright, and that's all for week 9, day 2. Remember, if you have questions about this lesson or any other lessons, please contact me, Ms. Fifield, or Ms. Fisher, and we'll be able to help you out. Also, remember that you can go on Zern for more practice. Alright? And I'll see you guys next week or in a couple days for week 9, day 5. Bye.